Hi, everyone. So now that we have learned the three methods of solving systems of linear equations, graphing, substitution, and elimination, today we're going to get a little practice with elimination, as well as trying to think about comparing elimination versus substitution when one method might be better than the others. We'll also look at word problems again and see what type of structure, maybe there's a pattern that will make us think, hey, this is going to result in a system that will require substitution versus elimination. So without further ado, here's your first question. I'm asking you to solve it using elimination, and I want you to think about why it makes more sense to solve this system by elimination than substitution. So go ahead. So the reason why elimination makes most sense is substitution, we need to be able to isolate a variable. And in this case, to isolate any of the variables, I would have to divide by something. And by these divisions, it would result in fractions. Now, you can always divide, and if it doesn't result in fractions, go right ahead and use substitution. But otherwise, elimination makes the most sense. Now, my goal here is I'm going to eliminate the x term from both variables, from both equations. And the reason why is just by multiplying by 2, I can create a common coefficient of the x terms. And as you just saw, I almost forgot to distribute. So don't do what I did and don't forget to distribute. So I've just created a common coefficient of 6 for the x terms. I could have done the y terms as well by multiplying the first equation by 7 and the second equation by 5. But that's 2 steps versus 1. I'm now going to line the 2 equations up, and I'm going to stick with orange for this one, and I'm going to do green for this one. Well, because my goal is to eliminate the variable terms, and since both of these are 6x, to eliminate them, I must subtract them. So all of a sudden, I have a 6x minus 6x. That becomes a 0x. I have a negative 10y minus 7. That's a negative 17y. And I have a 52 minus a negative 16. And that therefore becomes a plus 16, and we get 68. Well, I can now ignore this 0x and actually just get rid of it and divide both sides by negative 17. I get y is equal to negative 4. I can then go to either of my original equations. It does not matter. I'm going to take the first one and say 3x minus 5 times negative 4 equals 26. 3x plus 20 equals 26. Subtract the 20. Get 3x equals 6. Divide by 3. X equals 2, so therefore the solution to the system is 2 comma negative 4. Again, the reason why elimination makes more sense is it's not easy to isolate any of the variables in either of these equations. Here is the second practice problem. This time I ask you to do substitution, and again I ask you to think about why it makes more sense to solve using substitution. Go ahead. Now, this one is better for substitution because we already have a variable that has been isolated, so I can now just take this and substitute it in for x. So 6 multiplied by 2y plus 15 minus 2y equals 40. 12y plus a 90 minus 2y equals 40. These combine and we get a 10y plus 90 equals 40. Subtract 90, I get a 10y equals negative 50. Divide by 10 and I arrive to y equals negative 5. I'm now going to take this, and again, it doesn't matter which equation I plug it into. But the second one will definitely be quicker because it's x equals. So I just have to do this component. I get x equals negative 10 plus 15, x equals 5. So my solution is 5 comma negative 5. And just for the sake of proving it, if I go to this equation, I can actually plug that in and get 6 times 5 minus 2 times negative 5. Well, that's a 30 plus 10, which in fact is 40. So it works for both equations. So I know it's going to work. It's just that little extra just to check. And again, this makes sense to use substitution because we already have an isolated variable. So here's practice 3. Solve it with either method, because actually either method will be fine. So go ahead and decide which one you prefer. So you'll see that I solved this on the left in elimination, on the right in substitution. On the left, I created a common coefficient of 2 and therefore had to do elimination by subtracting. I was able to find y, substitute it into the other equation, and find x. On the left, you'll see right here that I had to rewrite it by isolating x first, and then I substituted in, but it resulted in the same exact answer. So if it doesn't matter, you can sometimes use whichever method you prefer most. So here's our conclusion. When a variable can easily be isolated, usually already has a coefficient of 1, well, substitution can work easily. When a variable cannot be isolated easily, well then usually elimination's the best, otherwise you'll probably create fractions. If both work, pick your preference. And I wanted to make a comment here. The reason I'm not talking about graphing is we're looking at algebraic right now, not graphically. So that's why we're comparing these two. All right. So we're now going to take a look at word problems. Now this word problem is going to result in one that is sort of set up for elimination. And we've had similar situations to this when we were in our last unit, when we were just starting to model inequality or equations. So if we take a look here, there are two topics being discussed. And the two topics being discussed are the number of cards being sold and the money raised from those. But so our two unknowns here are number of small cards and y, the number of large cards. Well, I see that we have a total of 25 cards. Well, total means add up. Okay, so x plus y equals 25. So this equation is therefore representing the number of cards. Well, that must mean the other equation must represent the money earned from them. Well, how much have I earned from small cards? Well, it's 3 per card. So 3x represents the money earned from small cards versus 5y, that represents the money earned from large cards. And by putting them together, I get the total of 95 raised. Well, again, you could do substitution here because I have both the x and y in the first equation having coefficients of 1. But I'm asking you to practice elimination today. And so therefore, I'm going to change to green and I'm going to eliminate the y term. I'm going to multiply this by a 5. That gives me a 5x plus a 5y equals a 125. So this resulted in that. Now I can actually do the work. I'm going to do the work in blue. I'm going to subtract 3x minus 5x. That's a negative 2x. 5y minus 5y, that disappears. A 95 minus 125, that's a negative 30. I therefore divide by negative 2. I get x equals 15. That means 15 small cards. I'm now going to think about how many large cards. So this is what I did first. So let's see, I first did this, I then did this. And then over here, I came and I thought to myself, okay, 15 plus y is going to be 25. So y equals 10. And last but not least, I'm going to write my sentence and say they sold 15 small cards and 10 large cards. So there's our first example. If you don't understand it, make sure that you come into the Google Meet and ask me some questions. Otherwise,